Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you're doing well and you are ready for today's show. Because we have, you guessed it, Ralph Bond. He joins us every single Friday to talk about 4 amazing stories, plus a little extra. We'll get to that later. And these are all stories that you definitely should hear about because odds are, well, some of these, like the first story, we're going to talk about an internet speed that puts anything you've heard of before to shame. It is incredibly fast, and that got some wider media attention as well. But we have stories like that. We have stories about how to slash your AC bill. Spoiler alert, it involves some pretty cool technology. And then, of course, one more story where, we haven't perfected smell-o-vision, but maybe in the future we can do taste-o-vision. And, story number 3 is going to speak to giving robots a sense of taste. So there you go. Now, with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, everything that we do here on Computer America, you can find on our website. And right at the top, you'll find a whole section dedicated to Ralph Bond, where we have all of the show notes, and those are crucial. He spends a lot of time on them. He really lays it out. And then, of course, he provides sources, links, videos, things that if you are simply listening to us or, I was about to say tasting us as well, but no, that's not there yet. Maybe in the future. But if you are simply listening to us and you want to see what we're talking about, come on out to Computer America, get the show notes, and you can get the links in to the articles and the videos. So, all that being said, let's go ahead, bring Ralph on, and just have a fun time with it. So, once again, he is our science and tech trends correspondent, joins us every Friday to talk about amazing stories that you probably haven't heard about. And Ralph, welcome back onto Computer America. How you been?
Oh, it's great to be back. And for people that are new to the show, let me set the stage for you. First of all, welcome. So what Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in all kinds of things. Artificial intelligence, of course, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, space research, physics, all across the board, you name it. But most important of all, this is the key thing here. We're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And actually, before we even get started with stories, Ralph, you know what I found time to do this week, which I encourage everyone, especially listeners of this show, I'm sure they are guiltier than most. This week, Ralph, I went through my cord bucket, my big pile of cords that I just have sitting in the corner of my office. Turned into a Griswold knot, if you know the scene from Christmas Vacation.
Yes.
Yeah. Do you have one of those buckets, or are you much more organized than I am?
I used to have a great big bin in a storage loft area full of all kinds of legacy cables and connectors. And fortunately, here in Hillsboro, Oregon, where I live, just outside of Portland, we have a place called Far West Recycling, and they'll take old cords. And I don't know what they do with them. They may strip them out for the metal or whatever, but I was just so glad I could just dump all that stuff. I mean,
Nice.
Decades worth of crazy cables, old, outdated cables that no longer apply, like ancient printer cables that everything's gone USB, right? So in the old days, though,
Or
there were all
Wi-Fi,
these different flavors, right?
Yeah. Or even just Wi-Fi, where, cables are just out altogether unless it's a power cable.
Yep.
Ralph, I went through all my cables, wrapped them all up nicely, taped them up with painter's tape, and sent them off to, I think we just did like Goodwill, just dropped them all off there. I'm sure someone out there is looking for a legacy cable that they just can't find for something. So I was like, donation's a pretty good place. Although I will say that I went to go set up my wife's printer, and I thought I donated the power cable to it because I was like, I have one of these. Turns out it's like a circle instead of like a circle square. And I didn't really. But anyways, hadn't donated that particular cable just yet. Almost did, but didn't. But
yeah.
Regardless, people go through your bins, recycle. Find somewhere to take it like Ralph did, or donate it to an organization that can kind of preserve these kinds of things. But other than that, Ralph, get clean, get organized. It's spring cleaning in July. But otherwise, let's go ahead and jump into our stories and let's get started on these. So for those out there who are watching the video, we appreciate it. You can see, and of course, by the time that you hear this, you'll be able to follow along in the show notes. Ralph sends those along beforehand. Really appreciate that. And you can see that we're going to start with story number 1. And again, an internet speed that, Ralph, people are like jealous when they have Google fiber, or some of these other smaller carriers provide 10 gigabits per second here and there. That's amazing speeds, but this story takes it to another level.
Yeah, it sure does. And our first story today comes from livescience.com. And it has been alluded to in the beginning. It was also picked up, of course, by many other science and news-related services. But the headline here is Japan sets new internet speed record. It's 4 million times faster than the average U.S. broadband speeds. 4 million times faster. Wow. And Ben mentioned the show notes, folks. In the show notes, I have not only the link to this article, but I have a link to the team's official statement and other articles and so forth that you can come and check out. But let's get into this. Researchers in Japan have shattered the internet speed record, achieving a jaw-dropping data transmission rate of 125,000 gigabytes per second. Again, roughly 4 million times faster than the average U.S. broadband speed. Wow.
That is, I'm sure they're going to give us numbers for how, just how much throughput that is, but that is like incredible.
Yeah, it's beyond comprehension, frankly. But going on here, the record-breaking internet speed was achieved by researchers at Japan's National Institute of Information and Communications Technology, and they collaborated with Sumitomo Electric Industries to develop here's the key how they did this, 19-core optical fiber that made the breakthrough possible. And this is where it's good to come to the show notes because we have an illustration from the research paper that shows an image, a cutaway image of the cable showing the 19 cores that made this possible. And going on about how did they do this? Well, researchers developed a new fiber containing 19 cores packed into a cable just 0.127 millimeters wide, the same size as standard cables. And we're going to explain that a little bit because I thought, wait, what standard cable are they talking about? We'll get into that. And this design minimizes light fluctuation and data loss. Now, a side note, real quick here, a cable with a conductor size of 0.127, which is the size of the cable we're talking about, is typically used in low voltage, high speed data transmission applications. And in the show notes, this is one thing I do, because a lot of times when I read these articles, Ben, I go, they assume I know what's going on. They assume I get it about a 0.127 millimeter wide standard cable. I said, I want to know, what is this? I insert additional information into the show notes that's not in the articles to help me and you understand what the heck they're talking about. So you can read all about the ribbon cables and multi-core shielded cables and other things that this technology is used for in this kind of cable.
Gotcha. Yeah. And I, all of this, kind of reminds me of a joke that beforehand, Ralph, like when it came to internet speeds, did you ever hear about the Jet Propulsion Lab back in the 70s and the joke about the station wagon? So
lay it on me. Sounds good.
Yeah. No, it's kind of the punchline. The story is that they were setting up all of these networks and data transfer cables and whatnot, and you would get transfer rates of 1 kilobit. Back in the 1970s, 1200, 2400, bits per second, which is like 1.2 kilobits. Ralph, like, the transfer rates were really slow. And, the higher ups were like, what's the fastest way to transfer this data from the Jet Propulsion Lab, which was like 6 or 7 hours away. And the punchline is, Ralph, never underestimate the bandwidth of a station wagon full of magnetic tapes hurling down the driveway. I'm sorry, hurling down the highway, not
That's
driveway,
funny.
highway. So
That's funny.
it may, and that's even true to this day, where if you want the fastest data rates, putting everything on hard drives and driving it in a car down the highway and delivering it to its end destination is in a lot of cases faster than any transfer speeds. That's something I would say to people until a story like this. And again, this is in a very, very highly controlled research setting, but still, this finally kind of blows that out of the water. It's incredible.
Right. And you make a really good point that's perfect for where we are in the story recap here. Highly controlled, experimental, lab-based situation, folks. And this also is an indication of the kind of stories Ben and I typically do on Friday. Most of the time, they are bleeding edge, early research, hence trends in science and technology. And so with that in mind, let's talk about the experiment they did. So they did a long distance transmission experiment, and the data in question that was 4 million times faster than your average home USA broadband speeds, the data traveled 1,120 miles, about the distance from New York to Florida, by looping through the system in the lab 21 times, showcasing the fiber's strength over vast distances. So they simulated a 1,120 mile transmission. And this speed is more than double. And this was something I didn't know too. We're talking about this incredible speed thing. Well, there's sort of a staircase history of this race to increase speed, because the speed is more than double the previous record of 50,250 gigabits per second set last year in 2024. So I didn't realize that all these incredible speed tests and experiments were going on, and this is just the latest milestone they've achieved. And because the cable matches existing dimensions of a standard cable that we talked about a moment ago, it could be deployed without overhauling current systems. That's so key, Ben, when you're talking about deploying something like this, right? And global impact, well, with data traffic expected to surge, thanks in part to data centers. I live in Hillsboro, Oregon, outside of Portland. I just did a little bit of research, found out my little town, which has, well, not that little, 110,000 people, which is not huge. We already have 15 data centers, 15. And
Ralph,
there are 10 more on the drawing board to go into this, what used to be farm country.
Ralph, it's your town might be outnumbered soon. The robots might be outnumbering the people in Oregon soon.
Yeah, that's true. So, of course, with data traffic expected to surge, again, due to data centers in large part, this innovation could revolutionize long-haul, high-capacity internet infrastructure. Now, this is a really interesting thing. In the article, they talk about at this speed, the speed that they achieve, the 4 million times faster than the average U.S. home broadband, you could download the entire Internet Archive in under 4 minutes. And I go, Internet Archive? Yeah, what's that? Added research in the show notes if you're like me and going, duh. Internet Archive refers to a massive digital library hosted by archive.org. It's a nonprofit project founded in 1996 with the mission of providing universal access to all knowledge. And here's what it includes. The show notes have all the details. I'm just going to give you one highlight to blow your mind. Over 562 billion, with a B, web pages via Wayback Machine, millions of books, including rare and out-of-print titles, and on and on and on. You can read all the details in the show notes. Now, all of that in 4 minutes, they said a second ago. Yeah, under 4 minutes, the entire mass at the speeds the Japan team have come up with. I rest my case. Blows my mind.
I was just reading, and this kind of speed, it may seem very excessive, but in some reading that I did recently, it was talking about data and the amount of data, Ralph, and they're saying that like humans are creating, I want to say we're doubling the amount of data that we have every 2 years or 18 months. Like it's not just that, we have a lot of old data, but we are creating more data than has ever been recorded in human history every like 2 years. So the need for this seems, when would we ever need this? And you just don't want this to be the bottleneck, for things to be able to transfer and talk to each other. So much needed, much needed.
You've just inspired the Moore's law of data.
Mm-hmm. Yeah, it's really there. And by the way, the Wayback Machine, yes, when I thought of the Internet Archive, Wayback Machine is what I go to. You can go there, find some really cool old websites if you haven't checked out before, Ralph. And even going all the way back to December 27th, 1996. You can go there, and if you're watching the video portion, you can see it up there. This is the first ever iteration captured by the Wayback Machine of Computer America.
Oh,
you can, you can receive, let's see, so on Craig's website, you have Explorer, CCA, Spotlight, Hot Off the Press, Crossman's Top 10. You can receive the entire lineup for the current month, emailed right there. That's right, Craig had an email list in 1996.
You should add it to the show's webpage as a sort of a fun history or archive or something. That's charming. That's so great.
Yeah, there you go. So you could download websites like this in a fraction of a second with story number 1 speed. So, Ralph, there you go. Very cool story and very, very necessary, I think, with the growing rate of data centers, like you said. So, cool story number 1. Story number 2. Let's go ahead and jump into it because, here in the Northern Hemisphere, we're dealing with something called summer. No one sees it coming. Every year, we're all caught off guard by how hot it is and how miserable it makes us all. Well, story number 2 might be the solution. A solution.
No, this is really great. It comes from an outfit called, and it's a fun website too, by the way, Times of Innovation, runtogether.com, timesofinnovation.com. Headline: Breakthrough U.S. thermal coating cools buildings by 36 degrees Fahrenheit, helping to slash AC bills and power use and so forth. And friends, this is something that Ben and I get into occasionally here on the show. Construction industry, the building industry, if you think it's boring and dull and it's just hard hats and getting people dirty, and no, high tech is really, really penetrating the construction industry every single day. It's just so fascinating to me anyway. But let's get into this story here. A new AI, of course, a new AI enhanced thermal coating for buildings can cool a building up to 36 degrees Fahrenheit. Now, for the rest of the world, that's approximately 2.2 Celsius, significantly reducing reliance on air conditioning. Oh, wow, how wonderful, right? The technology was developed. Oh, and Ben knows this. I'm a huge fan of collaborative research. This one's great. The technology was developed by an international team of researchers hosted by the University of Texas at Austin, Go America, Shanghai Jiao Tong University, National University of Singapore, and the last one's in Sweden, and I have no clue how to pronounce it. It's UMEA, Umeå University in Sweden. So look at that.
Yeah.
Texas, China, Singapore, and Sweden. Wow, love it.
You know what ties all of those places together? Because that is really a very multinational group. They all have weather, and it's so it kind of makes it all their problems,
That's true. So the building coating reflects a large portion of solar heat and adapts in real time to environmental conditions. And one of the most remarkable aspects of this breakthrough thermal coating for buildings is its integration of artificial intelligence technology. And I inserted this because it's a key distinguishing thing. We're not saying this coating is doing this. Well, let me try this again. It has the AI that's involved with this has to do in the development, the discovery of what's the right mix of ingredients to make this thermal coating. So it's not AI doing things in real time. It's AI helping them create a coating that instead dynamically responds to the environment. I'm sorry. I hope this is not too crazy and unclear. So through the use of AI algorithms in the development phase, the coating is able to adapt to changing environmental conditions in real time, optimizing its performance based on factors such as outdoor temperature, sunlight intensity, and even building occupancy. What? Wow. Huh. The AI in the University of Texas at Austin's thermal coating project isn't controlling the material in real time, as I mentioned a moment ago. It was used in the design phase. I want to keep stressing this, to engineer the coating's properties before application. And here's how AI played a role in the creation of this coating, this material. Researchers developed a machine learning framework to create thermal meta emitters. Boy, that sounds geeky. These are materials that can selectively emit heat and specific wavelengths. And you'll love this, Ben. This is a classic example of how AI plays a role in research and development of products in all fields. So the AI explored over 1,500 material combinations, optimizing for cooling performance and energy efficiency. Great example of AI.
Yeah, this is kind of the proposed offset because Ralph, you just talked about the incredible number of data centers that are going up, have gone up, and will go up. And there's so much environmental impact. There's so much more electricity usage. There's so much more reliance on everything that AI is supposed to be cutting edge, innovative, and help mitigate all these problems by just being a little bit more intelligent than we have before. And I think this is a great highlight of that.
Yeah, it certainly is. And the next part of the article we're going to highlight is so important in understanding how AI is being used in research. And that is something called inverse design. Let's explain. So going on here, instead of manually testing the materials, the AI used something called inverse design. It started with the desired thermal properties and worked backward to find the best structure and composition. So let's put it in even more friendly terms. You could say, I would like to have a bicycle with pink tires. And I would like, it's what, for example, when you go to your Copilot or any of these AI agents and so forth, and you say, create an image for me of a teddy bear wearing a cowboy hat. That's what we're talking about. You explain what you want. The AI works backward to give you the result. So that's the technique that's used here in developing this building composite or coating. This approach dramatically expands the design space, allowing for complex 3D geometries that outperform traditional thin film coatings for buildings. And the key to the effectiveness, of this thermal coating lies in its advanced composition, which is designed to reflect a significant portion of the sun's heat away from the building. And by leveraging the principles of heat reflection and dissipation, this technology ensures that the interior spaces remain cool, even in the hottest weather conditions. And as a result, occupants can enjoy a comfortable indoor environment without the need for excessive air conditioning. It doesn't replace air conditioning, folks. It just helps, leading to lower electricity bills and reduced carbon emissions. And you might say, well, where would we use this? Of course, residential and commercial buildings. But there's more. This technology, interestingly enough, this coating could have potential use in textiles, vehicles, and even spacecraft for thermal regulation. What? And again, remember, in their experiments, in their tests, it was able to cool buildings about 36 degrees Fahrenheit cooler than those in comparison with just standard white or gray paints. Wow.
Right. Yeah. And for the video portion, if you're seeing the image, that's the image that they kind of have of the three different coatings, and the middle one being the new paint that they developed. I'm sure that anyone who's been to a larger city and they see all the high rises, they see all the roofs, and they're like,
oh boy,
hey, that this would save a lot of energy. So, kudos to that. And good job to America, China, Sweden, and what was it, Australia?
Yay.
was the last one?
Singapore.
Singapore. That was
Yay.
it. Very cool. So, story number 2, you can see it there. And by the way, I had to dig a little bit. I don't know why that article didn't include a link to the actual journal, but that was in Nature. That they published that.
Good one.
So,
Thanks, Ben.
So, there you go.
Maybe add that to the show notes. That's a good point.
I will definitely include that in the show notes myself. So there you go.
All right.
Story number 2. Story number 3. Let's go ahead and go on down and talk about something that's been on the show before. You may remember the friendly name. You've never met the guy, but you've heard his name, Graphene. He's everywhere, and he promises to do so much, but he never shows up. So, we'll see what happens this time. Story number 3, and let's talk about graphene. And like I was saying before, not smell-o-vision, but giving robots a sense of taste. And I guess that can open up a whole new world of possibilities. So story number 3.
Boy, you bet. Absolutely. And this comes from phys, phys.org, short for physics.org. And the headline here was irresistible. Graphene-based artificial tongue achieves near human-like sense of taste. What? Ben, you and I have seen over the past many years developments in artificial skin, artificial this and that, simulations of biological things for possible robotics use and other uses as well for prosthetics and so on and so forth. And this just blew my mind. Again, artificial tongue. Oh my gosh. Okay, so let's get into this. And again, we do have the link to the research paper in this case on the show notes. Now, scientists from several Chinese universities have developed a graphene-based artificial tongue that uses, no surprise, artificial intelligence to mimic human taste perception with remarkable precision. And here's the essence of the innovation. Let's talk about the core features and functionality. Well, first, a graphene oxide sensor built within a nanofluidic structure to detect chemical signals in moist environments, just like the human mouth. Wow. Then an integrated design combines both sensing and computing on one platform for real-time analysis. Oh my. And here comes machine learning, AI, trained on, the system's trained on 160 chemicals to recognize flavor profiles by tracking changes in electrical conductivity. Now, how flavor and electrical conductivity relate, I can't explain that. You can dive into the research paper and learn more, but just seems like a fascinating, symbiotic relationship. I don't quite get it.
I'm sure when you really dig into the science of it, I'm sure it's all chemicals. It's all that interacts with electricity in different ways. I'm sure, actually giving robots taste is going to be a little bit weird to us. We can't just say, oh, this is salty. It's like you have to teach it what salty is. So makes sense.
Yeah. And we're going to find out later too. It's beyond just robotics, but we'll get to that in just a moment. Let's talk about the performance and accuracy of this artificial graphene-based tongue. Well, it has 98.5% accuracy with known flavors, sweet, salty, sour, and bitter, and 75 to 90% accuracy with 40 unfamiliar flavors. So they not only took the typical things, sweet, sour, salty, bitter, but they also said, let's see if it can deal with things it hasn't encountered before, 40 unfamiliar flavors. And again, 75 to 90% accuracy is pretty darn impressive. And it's capable of interpreting complex flavor blends like those found in coffee and cola. Now, Ben, we mentioned this in passing just a moment ago. Applications, where can this be used? Well, of course, robotics is one thing that could happen, but here's the thing that I found so inspiring: restoring taste perception in individuals affected by stroke, viral infections, or degenerative diseases. So there's a really inspiring use for this. Now, future uses, this is really interesting too, Ben. Get this. Imagine this for food safety, quality control, now, and even robotics, of course. Any field needing intelligent taste recognition. Wow.
Yeah, there are those people that work in laboratories and all over really all over the world. I've seen them on television. They do these documentaries and they, make new flavors of Coke. They do testing, quality control for like coffee. They do quality control for, tons of different food and beverage companies. Ralph, imagine instead of having just one guy that's just super good at his job and, he does like a sampling, 1 out of, 1 out of 100,000, whatever bottles of soda or whatever it may be. What if you have these things just kind of laid out, or not like I'm just picturing like 1,000 tongues all just laid out, but no,
No, yeah.
essentially robotic tongues, being able to test every batch of every product, and the quality just goes up. Less wasted product, you can catch it sooner. I mean, efficiency just goes through the roof, and more food gets produced, less food gets wasted, all that good stuff.
Absolutely right. And now to wrap things up real quick here with this story, and this is indicative of the trends and early research theme that often is part of every story that Ben and I do. So the article then talks about challenges and next steps. Remember, early research here, folks. Currently, this solution, if you want to call it that, is too bulky and energy intensive for real world deployment and use at this moment. But of course, the researchers aim to miniaturize and optimize power consumption for broader applications. So we may be looking at 5 to 10 years, who knows? But what a fascinating idea. Artificial tongue.
Yeah, no, it would have so many applications out there, which they kind of highlighted. But hey, maybe the robotic tongue can actually get, Ralph, I don't know if you've been to like a really snooty coffee or wine place, and like, this coffee has hints of hints of chocolate and this and that and the other, and it's like, it's all kind of bitter to me. Like, maybe they'll get what they're talking about, because my palate is just fine-tuned for like goldfish. Like, that is about the level of complexity I'm at. So who knows? Yes. Story number 3, very cool. Story number 4, let's go ahead and skip on down, and let's talk about Eyesight. And Ralph, go ahead and tell the nice folks what story number 4 is traditionally, but this one is dare I say, a sight for sore eyes. So there you go.
Great. Absolutely perfect. This comes from good old Popular Mechanics. Excuse me. And the headline is, scientists found the staggering natural switch that could bring back your eyesight. Subhead: millions of people live with vision loss, and we thought was permanent. This may change the equation. So this is really, really cool stuff.
By the way, real quick, if you're watching the video portion, you can see there where, pulled up Popular Mechanics.
Right.
You also have another source there, but they have, kind of a paywall, which is, fine. All publications are more than entitled to, kind of do their thing. Ralph, because we're doing an article on restoring eyesight, their version of the paywall, which you can see right here, kind of takes the article and just blurs it out, so you can't see anything. Yeah. And I was like, is that a joke with, like, the topic of the article? But no, I think that's just how they, kind of censor their articles. But I was like, is my eyesight going? Is this just timely?
Yeah, that's their pass-through test you got to pay up to see.
Yes.
No pun intended. Okay, so let's start off here with the beginning. Researchers at the Korea Advanced Institute of Science and Technology, hooray for South Korea, have developed a groundbreaking drug that restores vision by regenerating retinal nerves, making the first long-term neural regeneration in mammalian retinas. Wow. Okay, so let's get into how this works. The drug targets something called PROX1. That's PROX and the number 1 run together. This is a protein that blocks retinal regeneration. And I said, PROX1, okay, I have to know a little bit more about this. So I inserted some additional research here into the article. PROX1, which is Prospero homeobox 1, that sounds geeky, is a homeobox transcription factor. Okay, very geeky. A type of protein. This is a type of protein that binds DNA and regulates gene expression, especially during development. Super geeky, folks. But in mammals, PROX1 accumulates in the Müller glia cells, I hope I'm pronouncing that right, after retinal damage. So this PROX1 accumulates in cells after retinal damage, preventing them from becoming regenerative stem cells. So the culprit in this whole deal is this PROX1 stuff. And a little side note, the Mueller glia cells are the principal support cells of the retina. Think of them as the retina's built-in maintenance crew and emergency responders, a clever way of putting it. That's another little aside that we have. I have more information about those guys in the show notes if you want to learn more about these glia cells. Now, by using an antibody to neutralize this PROX1, researchers enabled these cells to regenerate retinal neurons, so damaged retinal cells. Now, because of this antibody to neutralize PROX1, enabled these cells to regenerate retinal neurons. Great stuff.
Yeah, and don't get me wrong, scientists know way more than I did, way more than I'll ever know about, especially their areas of expertise. But Ralph, it seems like they're using the body's own mechanisms to then trigger repairing and that kind of thing, and it kind of makes me wonder, like, why isn't the body doing this on its own? And maybe
Absolutely.
maybe there is a more biological function that or a better reason that it just doesn't apply that way naturally, and they can kind of just work around. I don't know. It's I'm curious why it didn't work that way before, just naturally.
Yeah.
The eyes are pretty cool.
Well, yeah.
But yeah, I'm glad they were able to get it to work with that, with the eyes.
It is. It's so interesting. You think you have damage to your retina, and you think, why in nature, if there's a possibility to heal, why wouldn't it just, like, you cut your finger, you put a Band-Aid on, a couple of days later, you're okay. Why not in the eyes? And for some reason, this is happening with this PROX1 culprit. And they did figure out a way to get it out of the equation so that the retinal cells could regenerate. So pretty interesting. But going on here a little bit about some of the results they did with their testing on mice. Thank you, mice and rats. I always bow low to thank you for your contributions to science. In mouse models with retinitis pigmentosa, the treatment restored the photoreceptor layer and significantly improved vision. The effects lasted over 6 months, which is in this field a major milestone in retinal therapy. So again, we're talking about early research, folks. We don't have a solution. You can go and get eye drops right now and away you go. No. Time out. We're just early on here. So what's next with this? Well, the therapy that they've come up with is being developed by an outfit called Celliance, that's Celliaz Incorporated, which is a biotech startup from the Korea Advanced Institute of Science and Technology Lab. So think about MIT and spin-offs, companies that spin off from research from MIT. This is the same thing, but from South Korea. Okay, so the Celliance Inc., and I have a link to this company. Their website's really, really interesting. Clinical trials are expected to begin by 2028. And this could be a game changer for millions of people affected by degenerative retinal diseases like macular degeneration and glaucoma. So wow. And we should have mentioned that often we end the shows with something in medical science technology. And this is a great, great way to leave you, I hope, very uplifted and inspired.
No, it's in terms of trends, there's a few things that are as uplifting as I think medical trends. Because
Yes.
Ralph, even just since CRISPR back 5, 6, 7, 8 years ago, you have cures for diseases. Like I remember we did one it was like a balance issue, like an inner ear disease, and with like one treatment of a CRISPR derived
Right.
treatment, they're able to cure this like indefinitely, like this lifetime condition. And I think we're going to be hearing a lot more of those. This one uses not CRISPR but something something else. But either way, it's previously non-curable, incurable conditions that are we're knocking them out. Like we haven't. It feels like, Ralph, like until we cure cancer, it's that's like the holy grail up there. But
Yes.
we shouldn't shy away from looking at okay, we're knocking down glaucoma, macular degeneration, like this article was talking about. We're knocking out all these sickle cell anemia is something that they're kind of getting on the ropes. There's a lot of good news out there about medical technology. So I really appreciate you coming on every Friday and talking about these. It's something everyone should pay attention to. So there you go. So story number 4, and ladies and gentlemen, if you are following along, you may notice story number 4 is about where the numbers end, but that's not where the show notes end. The after story number 4, we have the honorable mentions, and these are stories that when Ralph goes out and kind of picks these out over the course of a week, he finds more stories than we can kind of fit because we try to keep this a little bit shorter for ease of listening. So if you want to find out more information, more stories, and check out these honorable mentions, you can go to Computer America, go to the bottom of the show notes for today's program, and you can, of course, find links to all of these honorable mentions. They're just as good, just as cool. It's just Ralph's not going to, kind of read them out to you, but you should definitely check them out. Either way, it's very, very cool. So, Ralph, we can at least give the nice folks the headlines and, tell people what they can find there.
Yeah, you got it. So the first one, we'll have 4 honorable mentions. The first one comes from space.com. Really wonderful website, by the way. Scientists extracted water and oxygen from moon dust using sunlight. And the subhead is, could it work on the lunar surface? This one's really interesting. Check it out. Okay, so the next one comes from another story from timesofinnovation.com. Headline, scientists propose nuclear rocket with solar wings to reach mystery planet in 7 years. What I like about this one, nuclear and solar wings together to give you propulsion. Pretty cool. So check that one out. Mm-hmm. That's really good. The next one comes from interestingengineering.com. Headline, U.S. firm's reactor, and the company in question is NuScale Power Corporation, to supply hydrogen and electricity for 400,000 homes and water for up to 2.3 million people. This is like this super machine. You've got to check it out. Really.
So for modern headlines, I could also read, U.S. firm will provide electricity for 400,000 homes or water for 2.3 million people, or power and water for one data center. It's really incredible what they can do. It's amazing. So there you go.
You got it. Oh, that's so true. And our last honorable mention comes from the United Kingdom's The Guardian. And researchers, and in this case it's at MIT, researchers create AI-based tool that restores aged, damaged artworks in hours. Art That's restoration amazing. Is a very, very specialized field. It's very delicate, all this sort of thing, and it's great. They're showing it looks like a medieval painting here that they restored. Check that out. This is a fascinating use of artificial intelligence.
I might even throw in a link that I saw, I think it was 2 days ago, and I'll probably throw it in the show notes since I'm adding some other stuff to the show notes. This one's also going to be there. This one was on the BBC like 2 days ago, and for those who are simply listening, not watching, they're taking ancient Roman plaques and glyphs and stuff like that, and they're using AI to read what's there, and then the AI will potentially fill in what is left. So another use of AI doing the exact same thing. So.
Wow, that's a wonderful corollary. Yeah, add that into the show notes as a link because that's too cool.
Yeah, and hey, if you haven't picked up on it, ladies and gentlemen, you can of course kind of pick up that anything that we talk about here on the program today, you can find in the show notes, and you should definitely check that out. So computeramerica.com for everything. Ralph, I want to thank you so much for for joining us, and everyone out there tuning into Computer America and enjoying these stories. I hope that you had fun and you are heading into the weekend with something a little bit more uplifting, positive, and hey, maybe something that you can take to someone and say, hey, I heard about this really cool article. What about this? Just something to share other than crazy headlines that you're going to get everywhere else. So, Ralph, I really appreciate it. Music means that we're wrapping up here. Ladies and gentlemen, as always, Computer America, until next time, have a great day. Thank you so much. Do something fun this weekend. We'll catch you next time. Bye, everyone.